All right, guys, before we get going on new material today, we need to have a quick factoring review. These are the steps to factoring. If you don't have them down in your notebook or haven't kind of memorized them at least partially by now, make sure you pause the video here and write it down, because once we get going on this first example, we're going to go quickly because this is just a review and you can pause the video. So our first example here in the top left, we want to factor this trinomial, okay? Remember our steps to factoring trinomials. Is it in standard form? Are there any GCFs? No, there's no GCFs. Yes, it's in standard form. So all we're doing is looking for factors of the first and last term multiplied together, which is 72x squared. We want factors of it that can combine to be negative 17x. Now, something we've been doing is using our calculator to find the factors of 72 by looking at the table. And without those in your hands, there's another way to do it, and it's the same way. You already know how. So we go into Desmos and we type in y equals 72 divided by x. So this is exactly what you typed in your calculator, except you already had the y equals there. But so just type in the y equals, and then instead of being able to go like second, look at the table that way, you just go to that little edit list. Okay, this little cog right here, a settings cog, and you can see this one says convert to table. Now, the one extra step you do have to do here is, because it's always going to start you from -2 to +2, okay, is to get it to go further down, you just click on the X value and start pressing the enter button, and you'll see it starts listing out the factors. Right there is where we turned around. So we're looking for ones that can combine to be 17. That actually is going to be 8 and 9, because when we combine those, they will become a 17 by addition. Now, we can't just use regular 8 and 9x, though, because we need them both to be negative so that they can add to be a negative 17x. Okay? Again, we're going fast because this is a review. Now we're ready to put everything into a box. So we draw our box. Our first term, x squared. Our last term, 72. Our new terms, negative 8x, negative 9x, and we're going to run greatest common factor here. We get an x out of the top row. We get a negative 8 because this is negative. We get an x, and we get a negative 9. Thus, our factored form is now x minus 8 times x minus 9. That's a review of factoring. That's the most basic type of trinomial we had. The next thing we had to do was sometimes we had to factor out a GCF or factor out a negative to make it standard form, and that's the case here. So we can't operate with this with a negative out front of this x squared, so we take that out. And when we take it out, it's actually not going to move away from that side. This is still going to be y equals. The negative one is just going to start out front now. So we have x squared minus 4x plus 3. It flips all the signs in there. Now it's time to factor. We need factors of 3x squared that can combine to be negative 4x. Well, that only factors of 3 are 1x and 3x. And if we turn them both negative, then you know it's going to add to be negative 4x. Here's where we can also use a shortcut we were using not long ago. If this is a leading coefficient of 1, it's technically called an easy trinomial, not technically, but it's called an easy trinomial, which means once we do this factoring step, we're actually already at our answers of -1 and -3. You can actually look back at the last problem and see that. This was another easy trinomial with a 1 in front. And once we got to -8 and -9, that actually ended up being our answer, -8 and -9. Now, I should do the entire factoring process here because going forward, we're going to need it. But on this problem, I'm going to use the shortcut just to save you guys some time in video watching. It would be x minus 1, x minus 3, and this is where Mr. Straw gets problems wrong all the time. He forgets about the -1 he pulled out in the very front. That is factored form. We're going to need that today. Next, we step it up a notch. You'll see there's a 3 in front of the x squared. You can think, oh, great, let's just GCF. Well, 3 doesn't go into 10 or 8, so there's no GCF here. But we carry on like normal then. Is it standard form? Yes. GCF? No. We multiply first and last terms. We're looking for factors of 24x squared that can combine to be negative 10x. Okay. Well, there's a ton of factors of 24, so maybe this is a good time to break out Desmos. y equals 24 divided by x. Click the little cog, turn it into a table, go down here and start pressing enter to get more factors. Okay, we can see it turned around here, 4, 6, 6, 4. I don't really need those last few. Okay. So these are the factors we're looking through, and we want ones that make 10. Well, 2 and 12 could make 10, or 4 and 6 could make 10. So we got two different ones to tackle. Let's start with 2 and 12 and see if we can make it work. 2x, 12x. Well, they multiply to be a positive 24. That's good. Oh, I need to make one of them negative. I guess that's that one. And now they're messed up because now they don't multiply to be positive 24 anymore. So it must be 4 and 6. 4x, 6x. If I make both of them negative, now I get negative 10. And negative times negative is positive. So now we're ready for the box. Okay. We draw our box. First term was 3x squared. Last term was 8. Negative 4x, negative 6x. GCF here is going to be a 3x. And down here will be a negative 4. Here's just a plain x. Nothing goes into 3 and 4 together. And here it's going to be a negative 2. Again, on a complicated one like this, I would suggest you multiply everything back into the box in your head to see if it works. 3x times x is 3x squared. Negative 4 times x is negative 4x. 3x times negative 2 is negative 6x. And negative 4 times negative 2 is positive 8. So it looks like it all checks out. We're ready to write our answer, which is 3x minus 4 and x minus 2. The final thing we're going to be reviewing today, and this will be on the homework, guys, these type of problems, is a difference of perfect squares. This is a very unique looking quadratic. Okay, no longer is it a trinomial, but still a quadratic because x squared is our highest power. All right. Now, what we're missing is a b term, b of x. It's just completely gone. You say, well, then we can't do the problem. Well, no, that would actually just be 0 of x. And so you could work this out like normal, and you would be finding 0 of x right there where I circled, but in this new problem. Or, as we've come to be fond of, you can use the shortcut. This is a difference of a perfect square, which is x times x, and a perfect square, which is 6 times 6. So this is what's called a difference of perfect squares. This is where it gets its name. Well, that means we can go straight to the answer. We know that this is x times x, and that becomes x and x. This is 6 times 6, but because it's negative in the middle, one of those has got to be negative. We tend to make the second one negative, and we call it a day. That only works on those extremely rare but quick problems.